Tigers. In this video, I am going to explain the concept of managing input and output console in C++. Every program takes some data as input and generates processed data as output. Following the familiar input process output cycle, it is therefore essential to know how to provide the input data and how to present the results in a desired form. We have used C-in and C-out with the operations of input and output operations, but we have not so far discussed as to how to control the way the input is printed in C++. C++ supports a rich set of I/O functions and operations to do this. Since these functions use the advanced features of C++ such as classes, derivative classes, and virtual functions, we need to know a lot about them before really implementing the C++ I/O operations. C++ uses the concept of stream and stream classes to implement its I/O operation with the console and disk files. The content here I am going to explain are managing I/O console, C++ stream classes, formatted and unformatted console I/O, and usage of manipulators. Managing I/O console. C++ supports a rich set of I/O functions and operations. It uses the concept of stream and stream classes to implement its I/O operations with the console and disk file. The C++ streams. The I/O system in C++ is designed to work with a variety of devices including terminals, disk, and tape drives. Although each device is very different, the I/O system supplies an interface to the programmer that is independent of the actual device being accessed. This interface is known as a stream. Once again, I repeat this. Each device is very different. The I/O system supplies an interface to the programmer that is independent of the actual device being accessed. This interface is known as the stream. A stream is a sequence of bytes. It acts either as a source from which the input data can be obtained or as a destination to which the output data can be sent. Okay. A stream is a sequence of bytes. It acts either as a source or destination. Source means from which the input data can be obtained, or a destination means to which the output data can be sent. The source stream that provides data to the program is called the input stream, and the destination stream that receives output from the program is called the output stream. So here in this picture you can see the data in the input stream can come from the keyboard or any other input devices. The data in the input stream can come from the keyboard or any other input devices. Similarly, the data in the output stream can go to the screen or any other output devices. Okay. As I told earlier, a stream acts as an interface between the program and the input-output device. Okay. A stream acts as an interface between the program and the input and output device. Therefore, C++ program handles data independent of the devices used. And then C++ stream classes. The C++ I/O system contains a hierarchy of classes that are used to define various streams to deal with both the console and the disk files. These classes are called stream classes. The hierarchy of the stream classes used for input and output operations with the console unit. These classes are declared in the header file IO stream. This file should be included in all the programs that communicate with the console unit. This is the pictorial representation of C++ stream classes. The class IOS provide the basic support for formatted and unformatted IO operations. Okay. The class IOS, the first topmost box, this provides the basic support for formatted and unformatted IO operations. The class iStream provides the facilities for formatted and unformatted input, while the class output stream provides the facility for the formatted output. The class IO stream provides the facility for handling both input and output stream. Here this is the IO stream. It provides the facility for both input and output streams. V classes, namely I stream with assign, O stream with assign and IO stream with assign, added assignment operator to these classes. So the class IOs provide the basic support for the formatted and unformatted operations. The class iStream provide the facility for formatted and unformatted input, while the class OStream provide the facility for the output, formatted output. This is the pictorial. The data is given in the table format. iOS contains the basic facilities that are used by all other input and output classes. And then iStream, it inherits the properties of iOS. It declares input functions such as get, getLine and read. Contains overloaded extraction operator. This means the input operator. OStream, it inherits the properties of iOS. Declares the output function put and write. Contains overloaded insertion operator, 2 less than symbol. That is the output operator. The IO stream inherits the properties of iOS and OS stream through multiple inheritance and thus contain all the input and output functions. Stream buff provides an interface to physical devices through buffers. It acts as a base for file buffer class used in the iOS file. So this is the pictorial format. This is given in the detail in table format. Okay. And then unformatted IO operations. The unformatted IO operations are overloaded operators, extraction, insertion, and put-off and get-off functions, and getLine and write-off functions. The first one is the overload operators, insertion and extraction operator. The objects cin and cout are used for the input and output of data for various types of overloading, insertion, and extraction operators. The insertion operator is overloaded in the iStream class and the extraction operator is overloaded in the OStream class. The input data, here this is the general format for the input functions. Cin, variable 1, variable 2, variable 2. The input data are separated by white spaces and should match the type of variable in the cin list. Operator overloaded operators, insertion and extraction operator. The operator reads the data character by character and assigns it to the indicated location. The reading for a variable will be terminated at the encounter of a white space or a character that does not match the destination type. Here this is the example declaration of variable using the data type integer. The variable name is code. In the input function cin, it gets the input 4525D. The operator will read the characters up to 8 and the value 4558 is assigned to the code. This is the output statement cout, extraction operator, item 1, item 2 up to item n. This statement will cause the computer to stop the execution and look for input from the keyboard. The input data from this statement would be data 1, that means item 1, item 2 and item 3. The input data separated by white spaces and should match the type of variable in cin list. The operator extraction reads the data character by the character and assign it to the indicated location. The operator will read the characters up to 8. I already explained that here. This is the general form for displaying data on the screen. Cout item 1, item 2 up to item n. The item 1 through item n may be variables or constants of any basic type. We have used such statement in a number of examples in our previous classes for cin and cout. And then put off and get off functions. The classes iStream and OStream define two member functions, get and put, to handle the single character input and output operations. There are two types of get functions. The first one is the get character and the get void. The get character version assigns the input character to its argument. The get void version returns the input character. And then the put off and get off functions. The function put off is used to output a line of text character by character. Cout.x and cout.ch. The variable ch must be contain a character value, and then cout.put of 68. This statement will convert 68 to character value and display the character D. That means the ASCII of D is 68. Capital D is 68. And then getLine and write-off functions. The getLine functions read the whole line of the text that ends with a new line character. The get function, the put function is used to output a line of text character by character. Here, the getLine and write functions, the both functions read, here the getLine functions read the whole line of the text that ends with a new line character. This function can be invoked by using the object cin. Cin.getLine of line, size, ended with semicolon. The function getLine, which read character input into the variable line. The reading is terminated as soon as either a new line character is read or size minus 1 characters are read. And then the write-off function. The write-off function displays an entire line. Cout.write line, size, ended with semicolon. The first argument line represents the name of the string to be displayed, and the second argument size indicate the number of characters to display. And then the formatted IO operations. C++ supports a number of features that could be used for formatting the output. IO class functions and flags, manipulators, and user-defined output functions. The first one is the IO class functions and flags. The first one is with the function to specify the required field size for displaying an output value. The second one is the precision to specify the number of digits to be displayed after the decimal point of a float value. And then fill to specify the character that is used to fill the unused portion of a field. And then set f to specify format flag that can control the form of output display. And then unset f to clear the flag specified. Defining field width, that means the width of function. The width of function to define the width of a field necessary for the output of an item. Here the example is cout.width of w, where w is the field width. The output will be printed in the field of w characters wide at the right end of the field. Here cout.width of 5. The output is cout 543. Here 543 will be assigned like this at the right end of the field. And then precision. Setting precision, we can specify number of digits to be displayed after decimal point while printing the floating point numbers. Cout.precision of D. D is the number of digits to the right of the decimal point. Here in this example, cout precision of 3, that means after the decimal, after the point, 3 digits only you have to specify here. Here cout square root of 2, that means 1.141. Like that, cout 3.14159 was given in the output, but only the first 3 letters will be printed. Filling and padding fill off. The unused portions of the field are filled with white spaces. However, the fill function can be used to fill the unused positions by any desired character. Cout.fill of ch, where ch represents the character which is used for filling the unused positions. Example, cout.fill of star, the unused position, the width of the text is 10. Here the input only is 5250 was given. The balance spaces are filled with the asterisk because you have given